In this video, we'll be going over an example in which we're asked to identify the points of discontinuity and state which ones are removable. So here we have the function f of x that is piecewise defined. For x values less than 0, it's defined as 1 plus x squared. For those greater than 0, it's defined as sine x over x. You'll notice that it is not defined at x equals 0. So right off the bat, you know functions can only be continuous where they're defined. I'll write that. Functions only continuous where defined. So right off the bat, you know x equals 0 amounts to a point of discontinuity. But let's look on either side of 0. So for x values less than 0, we have this polynomial function here, 1 plus x squared. Polynomial functions are continuous everywhere, so they're certainly continuous for negative numbers. On the right side of 0, we have this quotient of two continuous functions, sine of x over x. Sine of x is continuous, and x is continuous. So this quotient is going to be continuous wherever the denominator is not 0. Well, the denominator is 0 when x equals 0, but x equals 0 is not on this graph, is not within the set of positive values of x. So this function, this piece is continuous wherever defined. But right at 0, we obviously have a point of discontinuity because the function is not defined there. But remember that, that's first off, that's the only point of discontinuity that we're dealing with here. So only point of discontinuity is where x equals 0, because f of x is undefined there. Well, now we have to answer the question as to whether this point of discontinuity is removable. And remember, it's going to be removable, just right here, discontinuity is removable. So discontinuity at, I'll say, at x equals a, is removable if the limit as x approaches a of f of x exists. Remember, it doesn't have to be equal to a, or doesn't have to be equal to f of a, because if it was, this wouldn't be a point of discontinuity. But we have to know that it exists. Well, does it exist? Well, let's look at it's going to exist if the limits from the left and right are equal. So what's the limit from the left? Well, the limit as x approaches a is 0 in this case. Limit as x approaches 0 from the left of f of x. Well, that's just the limit as x approaches 0 from the left of 1 plus x squared. Well, that's just going to be this polynomial function continuous there. So it's going to be 1 plus 0 squared is 1. And the limit as x approaches 0 from the right of f of x, well, that's just the limit as x approaches 0 from the right of sine of x over x. Just remember, f of x is defined as sine of x over x for positive values of x. So the limit as x approaches 0 of sine of x over x, well, that's 1, right? Remember, this is our special trigonometric limit. So this is equal to 1. So we see these left and right limits are both equal. So I'll just say limit as x approaches 0 from the left of f of x equals the limit as x approaches 0 from the right of f of x equals 1. So this just means therefore the limit exists. Limit as x approaches 0 of f of x exists. If the limit exists, then the discontinuity at this value a, in this case x equals 0, is a removable discontinuity. And remember, that's equivalent to saying that we can redefine this function. Okay, so discontinuity is removable. I'll just say discont is removable. So we've already answered the question, but take it a step further. We can just say that, well, because this discontinuity is removable, we can redefine. So we can redefine f of x. We can redefine f of x to make it continuous. To make it continuous by setting the function value at 0 by setting, let's say, by setting the function value at 0 equal to this limit, which is 1, right? Setting the value. So if we set this function value equal to 1, so instead of this, right? If we had f of x equals 1 plus x squared for x less than 0, sine of x over x for x greater than 0, and 1 for 0 for, and this is for x equals 0, I should say 1 for x equals 0. Then we've turned this function into a continuous function because f of 0 is 1. The limits from the left and the right are both 1. So the limit as x approaches 0 of f of x, which was the only problematic point here, is equal to the function value at 0. But anyway, we've already answered the question, and the answer is the question was that, find the points of discontinuity and state which ones are removable. Well, we only have one point of discontinuity, that's at x equals 0, and it is a removable discontinuity.